Hello everyone, and welcome again to Nettle, the best platform around for distance learning in business, finance, economics, and much more. Please don't forget to subscribe to our channel and click that bell notification button below so that you never miss fresh videos and tutorials you might be interested in. Many thanks to our current Patreon supporters and YouTube members for making this video possible, and we'd also greatly appreciate if you consider supporting us as well. So please check the link in the description or click the join button below for more details. My name is Sava, and today we're investigating a very interesting and satisfying concept in international economics and econometrics, that is the gravity model of trade and how you can estimate it yourself in Excel. The gravity model of trade is a very inspired model that borrows heavily from physics, and it has been known, at least since Isaac Newton, that there exists the law of universal gravitation, or law of gravity, which means that two objects that are massive, that have masses, are attracted to each other with some force. And what Newton proposed is that this force of attraction between two massive objects is equal to the gravitational constant g times the product of their masses over the distance between the two objects squared. And this gravitational constant has been calculated quite precisely, and is one of the fundamental constants of physics that describe how the world ultimately works. And economists and econometricians have borrowed this concept to describe trade between countries. They hypothesized that trade is the same force of attraction, albeit not physical but economic, between two massive economies. That means economies that have non-zero GDP. And trade between two countries I and J can be expressed in terms of some constant. Here it is parameterized as exponent of some constant, and y we'll touch upon slightly later, times the product of the two masses raised to some powers, beta 1 and beta 2, so yi and yj would be the GDPs of country I and country J, and then it is all divided by the distance between two countries raised to the power of beta 3. You can see the analogy. The logic is that the heavier, the bigger the economies are, the more they have to trade with each other. If one economy becomes larger, it has more goods to sell or more goods to buy from the other one, and vice versa. And alternatively, if the distance between those countries is varied, it is easier or harder to trade, depending on whether they are closer together or further apart. So theoretically, at least as an analogy, this should work. But econometricians never take anything for granted. We want to test things. And to test the gravity model of trade, most commonly, the following equation is proposed. This model is multiplicative, meaning that trade is equal to a product of several variables. And you can estimate a multiplicative model in a linear regression if you take natural logarithms from both sides, with logarithms famously breaking products into sums. And here we can see the analogy. To estimate a gravity model of trade econometrically, we just take the natural logarithm of trade, and that is a nice linear expression that breaks down from this particular product. We expect a positive and significant coefficient for beta 1 and beta 2. The economies become bigger and they trade more intensively. So positive and significant beta 1, positive and significant beta 2 for the same reason. By the way, we also expect beta 1 and beta 2 to be equal in magnitude, because it doesn't really matter which country we put in first and which second. And then we expect a negative coefficient beta 3 that is a coefficient for the logarithm of distance between two countries. And then we add a random disturbance term, epsilon. So now, how to actually use real-world data to test the gravity model of trade, and how to approach the modeling? Well, here, the first bit of data that you need are bilateral trade flows. And these I've got from the International Trade Center. For simplicity, here I've got only the European countries, so 42 European countries that are geographically in Europe. And It is a 42 by 42 matrix with each element representing exports from country I to country J. For example, Armenia does not export anything to itself. Countries do not trade with each other in terms of international trade flows. Obviously, there is loads of trade happening within the countries, but we disregard it here as it's international trade statistics and international trade model. But every single other element, apart from the diagonal, is meaningful. For example, we see that Armenia and Azerbaijan do not trade. Perhaps that can be related to some political tensions, who knows? And we can see each and every cell of the matrix with each element here representing the trade volume in thousands dollars. Now, having obtained the bilateral trade flows data, we can look at country-specific data. Obviously, we need the list of our countries, we've got 42 of them, and we need their gross domestic product in $1 billion for the same year that they have recorded their trade data. Our sample is for 2001, simply because that was a very neatly available year from International Trade Center and for no other particular reason. And to calculate the distances between those countries, we have to make assumptions about which points do we want to calculate distances between. And the conventional and very convenient assumption is to calculate distances between countries' capitals. And here we've got the capitals of all of the 42 countries and their latitudes and longitudes. So basically, the coordinates of these points, we will calculate the distances between. Now, as per our data set, we have to map our pairs of countries in terms of the distances between them, in terms of the bilateral trade volume, and in terms of the respective gross domestic products. So here we have got 42 times 42, meaning 1764 pairings, some of which we'll have to later remove for reasons I'll discuss a little later. First of all, we use those indices, which is the index of country 1 from 1 to 42 and index of country 2 from 1 to 42 as well, to retrieve the trade flows from the matrix on the very first sheet. As we do not care which way the trade goes, we only care about the total volume of trade. So with some both of the elements, basically mirror images. So here, for example, for Armenia and Austria, with some those two cells. As we do not care which direction the trade goes, we're interested in total trade volume between Armenia and Austria, and we get $31 million. And that is exactly what we've got over here. So we sum up both directions of trade for our particular pair. Then we retrieve the GDP of a particular country in a pair. So here we would have the GDP of Armenia and GDP of Austria from this particular worksheet, provided by World Development Indicators from World Bank. And we also retrieve the latitudes and longitudes of capitals from the same worksheet over here. So here we basically are calculating the distance between Yerevan and Vienna. And how to calculate the distance between 2 points on Earth, basically on a sphere, or on an approximate sphere, as Earth is not a perfect sphere but can be locally approximated as such, using latitude and longitude. Well, for that we need the so-called Haversine formula that can be expressed using the radius of Earth, which we assume to be equal to 6,371 kilometers, and the latitudes and longitudes of our points on the sphere, of our two capital cities. And we code this function over here to calculate the distance between 2 points. And as a sanity check, this should return us that the distance between Yerevan and Yerevan is exactly 0 kilometers. And that's exactly what we get over here, meaning that the formula does work. And it also tells us that the distance between Vienna and Yerevan is approximately 2,400 kilometers, which is also quite reasonable. So here, having computed all of that, we need to figure out whether to include those observations into our final estimation sample or not. So first of all, we need to avoid the zeros here. Those would be either countries not trading with themselves, which we have to avoid regardless, and alternatively, if there is a pair of countries that do not trade between each other whatsoever. Coincidentally, in our sample that's not the case. All countries are in Europe, quite close to each other, and even if there are any tensions or if there are quite far apart, like Iceland and Turkey, they would still trade at least in one direction. So in our case, that's not an issue, but actually it's one of the limitations and one of the criticisms that are directed at the conventional parameterization of the gravity model of trade is that when we estimate it using a natural logarithm, we cannot really take into account zero observations. And there are modifications that are designed to address this particular concern. However, here we simply need to avoid zeros, simply because a pair Armenia-Armenia, for example, is not really informative for our model purposes. And alternatively, we need to also include pairs that we have already repeated. So for example, we have got Armenia-Austria pair, and here we have an Austria-Armenia pair, and we need to include only one of them. So basically, we need to include only those pairs where the value of the index B2 is less than the value of the index A2 over here. So basically only the pairs below the diagonal, and that would allow us to include every single pair of countries only once. So we include, for example, Armenia-Austria, and we do not include Austria-Armenia. And finally, for our estimation, we have got a narrowed down sample where we only include 861 observations. It's quite nice to figure out how many observations we have got and whether we have got any zero observations with non-trivial pairs. So here we can do the following manipulation. We can say that initially we have 42 squared observations, then we remove the diagonal, and then we divide it by 2 because, well, we had 42 squared observations, we remove the diagonal, and then if we divide by 2, we only remove the pairs we have already counted otherwise, and you get 861. That's the maximum number of observations we could have got, and we have got exactly 861 of them, meaning that our sample is the largest possible. We had no pair of countries that do not trade between each other, as I mentioned beforehand. And now we can finally estimate our gravity model of trade equation, regressing the logarithm of trade, natural logarithm of bilateral trade flow between the countries, onto a constant, and natural logarithm of their GDPs, as well as the natural logarithm of the distance between the two capitals. And then we can use simple matrix algebra to calculate the coefficients and the respective standard errors, and I point you towards my video on multiple regression with matrix algebra so that you can learn that in detail. Here we're concerned with the coefficients and their significance. Here we see that, first of all, the coefficients for GDP1 and GDP2 are both positive, quite less than 1, meaning that the trade gravity equation is not necessarily the same as the physical gravity equation, where those constants are obviously 1s, mass to the power of 1 times the other mass to the power of 1. However, they are positive and overwhelmingly significant, with t-stats in excess of 30, meaning that the result is undeniably significant. And in terms of the distance, we have got a negative coefficient, which is exactly what we would have expected, given the fact that countries that are further apart trade less, all other things held equal. And this coefficient is close to -2, that is here for the physical law of gravity, but is still less in magnitude than the one we have for the Newton's law of universal gravity, -1.6. However, it's still overwhelmingly significant, with a p-value quite close to 0, meaning that the presumption that we have elaborated on at the start, that larger countries trade more, all other things held equal, and countries that are closer apart trade more, all other things held equal, is fulfilled. And that's all there is for the economics of the gravity model of trade and its econometrics in Excel. Please leave a like on this video if you found it helpful. In the comments below, I'm eager to see any further suggestions for videos in business, finance, or economics you would like me to record. And please don't forget to subscribe to our channel or consider supporting us on Patreon. Thank you very much, and stay tuned.